Okay, so today's lesson is about matter and its classification and properties. So we've already done some lessons before this with regarding to physical and chemical properties and physical and chemical changes. Now we're going to focus more on the classification. So we have something called the particle theory of matter. It says that all matter is made up of tiny particles. There are spaces between the particles. Particles attract each other, and particles are always moving. So this is the particle theory of matter, which is a generally accepted theory, and we're going to talk more about what we're talking about when we're referring to these particles. So let's look at the classification system. All matter fits into one or two categories: pure substances and mixtures. So those are the two that we're going to look at right now. When we're referring to a pure substance, we're referring that all particles of the pure substance are exactly the same. They're nothing different. So a pure substance, all the particles are exactly the same. For a mixture, it is made up of two or more different kinds of particles. And the best way to understand this is to go over some examples that we're going to look at next. So, how can I even classify this further? In the category of pure substances, we can then divide it into even smaller categories of elements and compounds. And for mixtures, we can refer to them as homogeneous mixtures or heterogeneous mixtures. And again, we're going to go through examples of each to help you really understand what each type looks like. So let's look at the element that falls under the pure substance. At this point, you're familiar with our periodic table. The periodic table gives us all the elements that exist in our universe. Now, it is the smallest substance that can exist. You can't break it down into anything simpler. So for example, some of the parts of our periodic table, and we see examples here, Fe stands for iron, Br stands for bromine, H for hydrogen, C for carbon. It's made out of one atom. So what we see here, the yellowy orange ball, is an iron atom. It cannot be divided into anything simpler. Same with the bromine atom. That is the smallest unit possible that exists stable in nature. Same with hydrogen, same with carbon. These elements are made out of a single atom. And of course, it would fall under the pure category because it is only iron atoms. It would only be bromine atoms. It's the same particle. So if you were to have a sample of iron, that sample of iron is going to be made out of iron atoms. All of them are identical. So it's an element is a pure substance because it is made out of a single atom. So let's look at this. We have here a sample of pure copper. And that means this structure that you see, this sample that you see, is purely made out of copper atoms. So again, the same type of particle, in this case being the copper atom. So this is a pure substance. Pure sodium is actually a very soft, silvery substance. And this sample that you see in the picture here is made up of only sodium atoms. So again, another reason why it falls under the pure substance category. Okay, but what happens if we now combine some different atoms together? Now, we know the term compound. The term compound is referring to two or more elements, like the ones we saw before, that are chemically bonded together. Okay, so they're stuck together. Examples that you might be familiar with are carbon dioxide, right? That's the air that we breathe out, or at least part of it. CO2. And if you notice, CO2 consists of a carbon atom and 2 oxygen atoms. NaCl, that's referring actually to the table salt that you might sprinkle onto your food. And that consists of a sodium ion, and we're going to talk about ions later, and chlorine ion. And the most common that we are familiar with is water, and that is consisted of an oxygen atom chemically bonded to 2 hydrogen atoms. So you can see here is that we have the elements, which is purely the single type of atom. And then we have compounds, which is when different types of elements chemically bond with each other to form compounds. Now let's look at our mixtures. So a mixture is a homogeneous mixture is a mixture of more than one pure substance that is uniform throughout. And what that means by uniform throughout means you can't really see the different parts that it's made out of. So if you look at coffee, you can see that the coffee just looks like a brown liquid, but it actually is made out of the coffee that's been ground and water, but you just can't see those two different parts. It's not visible to you. Same with orange juice. With orange juice, it actually has the orange pulp plus water, but you can't see those different parts. It's all one unit, so you don't see that it is a mixture. It looks uniform, and that is what we refer to as a homogeneous mixture. And when I show you the other one, you'll see how different it is. A heterogeneous mixture looks like this. It is obvious when you look at it that you can see that it is made out of different pure substances. But they're not bonded together. They're not bonded together. If you look at oil and water in that glass, the oil and the water are not chemically bonded together. This is a mixture of water and oil, and it is visible, the differences between the two. You can see the oil, you can see the water, and that's why we call that a heterogeneous mixture. You can visibly see the components. Pizza, who doesn't love pizza, is a heterogeneous mixture. It is made out of more than one pure substance, and we can see the different parts. A collection of pebbles near a beach, right? That is also a heterogeneous mixture. They're not chemically bonded together. Each stone is a pure substance, but they're mixed together, and you can see the different ones visibly with the naked eye. And that again is an example of a heterogeneous mixture.